Hello and welcome to High Voltage Engineering. We'll be covering module 1.4. In this module, we'll be continuing this concept of conduction and breakdown in gases. So continuing from the previous lecture, we are talking about the Townsends criteria of the gaseous breakdown. Now there are 4 points to consider here. For a given gap spacing and at a given pressure, the value of the voltage V, which gives the value of the alpha and the gamma, satisfying the breakdown criteria, is called the spark breakdown voltage. Okay, so remember this term, spark breakdown voltage, Vs. That is the voltage which gives the value of alpha and gamma that satisfy the breakdown criteria. The corresponding distance at which the breakdown occurs is called the sparking distance. And the Townsend mechanism that explains the phenomena of breakdown is only at low pressures. So the Townsend mechanism is applicable only for low pressures and corresponding to the gas pressure and gap distance values of 1000 torr centimeter and below. That means Townsend mechanism is only applicable for this pressure and distance. The product of pressure and distance should be less than 1000 torr centimeter, for which the Townsend breakdown criteria is applicable. Okay. Now we come to the experimental determination of coefficient of alpha and gamma. The experimental arrangement is shown in this figure. It is visible properly. Okay, you have a DC power supply. The electrode system consists of two uniform field electrodes. So you have the electrode system here. The high voltage electrode is connected to a variable high voltage DC source. So this electrode is connected to a high voltage DC source of around 2 to 10 kilovolt. The low voltage electrode consists of a central electrode and a guard electrode. So you have the low voltage and the high voltage side of the DC. So on the top it is the high voltage and on the bottom it is the low voltage side. Okay, the low voltage side, it has a central electrode and a guard electrode. The central electrode is connected to the ground through the high resistance of an electrometer amplifier having an input resistance of 10 to the power 9 and 10 to the power 13 ohms. The guard electrode is directly earthed. The electrometer amplifier measures the range of current from 10 to the power minus 14 to 10 to the power minus 8 amperes. So the electrometer measures the flow of the electrons, or that means whether current is flowing or whether there is a breakdown in the inside the gap when the DC power is applied. Okay, it also has this guard electrode. This guard electrode is directly earthed in case of any total fault. It is basically a safety device, so it is directly earthed in case of very high current to protect the this electrometer. Let's say something happened and very high current starts flowing, so the electrometer can only measure to a range of 10 to the power minus 14 to 10 to the power minus 8 amperes. So that electrometer will get disturbed, or it might get damaged or destroyed. So we have the experimental determination of coefficients of alpha and gamma. The electrode system is placed in an ionization chamber, which is either a metal chamber made of chromium plated mild steel, stainless steel, or glass chamber. So we are talking about this circular container, that is the ionization chamber, which is either a metal chamber or a chromium plated mild steel or stainless steel or even a glass chamber, depends on the pressure the chamber can withstand. The electrodes are usually made of brass or stainless steel, because these brass and stainless steel, they are both corrosion resistant as well as the good conductor of heat. The chamber is evacuated to a very high vacuum in order of 10 to the power minus 4 to 10 to the power minus 6 torr. First, so this glass chamber is, all the air inside the glass chamber is taken out, so that you have a very high vacuum of 10 to the power minus 4 to 10 to the power minus 6 torr. Then it is filled with the desired gas and flushed several times till all the residual gases and air is removed. So you need, after bringing that chamber to a vacuum, now my desired gas is injected inside it, and it is injected multiple times so that all stray air gets out and only my preferred gas remains. The pressure inside the chamber is adjusted to a few torr depending on the gap separation, and left for about half an hour for the gas to fill the chamber uniformly. The cathode is irradiated using ultraviolet or UV lamp kept outside the chamber. Now we are triggering the gaseous breakdown. Okay. Now triggering this gaseous breakdown, we irradiate the cathode inside the chamber with the ultraviolet ray, and the UV radiation produced the initiated electrons, that is N naught, we have discussed N naught previously, by photoelectric emission. So we start our breakdown by injecting UV ray on the cathode, so that cathode release N naught amount of electrons. When the DC voltage is applied and when the voltage is low, the current starts appearing due to electrons and positive ions. Okay, so when the voltage is low, the current appears due to these electron and positive ion. This is shown in this figure, where the voltage becomes low. You can see the current increases and then goes down, then again increases, then again goes down. Okay, this is that graph I was talking about. You can see the current goes up and then comes down, then again goes up and then comes down. Okay, these records are obtained when the current is measured using a cathode ray oscilloscope. So this is the record taken from the cathode ray oscilloscope. When the applied voltage is increased, the pulse disappears. So initially for the small voltage, you will see pulses like this, and slowly when we increase the voltage, the pulse disappears. Okay, there will be, you can see the pulse slowly. In the second part, it slowly becomes, it is disappearing. When the applied voltage is increased, the pulse disappears and average DC current is obtained. Okay, an average DC current is obtained. That means you can see in this figure, where you have I with volt, I is plotted with respect to the voltage. Initially, when the voltage is low, you can have a pulse and the current increases, and the current then goes like this, and slowly as voltage increases, the current becomes uniform. So when the applied voltage increases, pulse disappears and the average DC current is obtained. The initial portion, that is the T0, this part, the current slowly but unsteadily increases with the applied voltage, and in this region and this region, T1 and T2, the current increasingly steadily due to the Townsends mechanism. This happens due to the Townsends mechanism. These two parts, the electron is released due to the Townsend mechanism, and beyond T2, that is this part, the current rises very sharply and a spark occurs. So here is the region for the current sparks. Okay, so this would be our experiment from this to get the alpha and gamma. Now we'll see how do we obtain the alpha and gamma values. Okay. The next part is that we have few more graphs to determine the value of alpha and gamma. The voltage current characteristic of different gap settings are obtained. Okay, so we set on with different gap settings and we will have different currents for different gaps. From the results, a log I dash I slash I0, that is the ratio of I and I0 versus the gap is plotted. Okay, so this is the zero distance and this is first gap is kept like this, second gap is kept like this. So first gap is this, second gap is this, and third gap is much more. So slowly you will see the current, how the current increases as the gap changes. Okay, so from the result, the log of I slash I0 versus gap distance plot is obtained under a constant field E. So we have a constant field E condition as shown here. The slope of the initial portion of the curves gives a value of alpha. So the slope of these curves for the initial portions gives the value of alpha. How do you get the slope? Slope is the tan of the angle between 2 points. Okay, so you have one point here, the other point here. If you draw a line, so this angle, you find the tan of this angle, you will get the slope. Okay, the slope of the initial portion of the curves gives the value of the alpha. Knowing alpha, gamma can be found. Okay, using the points on the later upturned portion of the spectrum. So here from this part the gamma can be obtained. Now you can have the same experiment with different pressures. Okay, now it can be easily seen that the ratio of alpha versus P and gamma are functions of E by P. Are functions of E by P. The spark over voltage for any gap length is Vs is equal to E into ds, where ds is the critical gap length for that field strength as obtained from the graph. It may be noted that if I naught, the initial current, is more, the average anode current I will also be more, and the relation log I dash I0 versus D plot remain the same because we are taking a ratio of log I slash I0. Okay, so this would be the end of the our class. Okay, we will continue for the next class. Thank you.